to definite integrals. First thing we need to do is we need to just know the properties. Alright, so some of these properties are kind of easy to figure out. You have already told me about number 1. If f is defined to x equals a, then the integral from a to a of f of x, what would it be? It's going to be 0. Because if we take the integral from 1 to 1, or from 2 to 2, or from -7 to -7, then our rectangles that we're drawing, they don't have any width, right? So it's just 0 for that. For the second property, if f is integrable on a to b, then the integral from a to b of f of x dx, oh my, what's that supposed to be? Let me see. Okay, I know which one it is. Okay, I didn't write this down, and I'm forgetting what property I had here. Is going to equal negative integral from b to a of f of x dx. So basically, this is what I was showing you with that very first part with the graph where we were going from -1 back to -2. If you switch the limits on your integral, it's going to change the sign of your answer. Okay, and we'll see some of those in a minute. For the third property, if f is integrable on 3 closed intervals determined by a, b, and c, where b is between a and c, then the integral from a to b plus the integral from b to c is going to equal the integral from a to c of f of x dx. We've been doing this as well, because whenever we were finding those areas under the curve, we take this shape plus the shape next to it plus this other shape next to it, and we'd add those all together to get the area under the curve from maybe 0 to 5 or something there. So we can just, if we have 2 integrals right next to each other, they share that interval there. We've got from 1 to 2 and then 2 to 7. We could just add those 2 together, and we've got from 1 to 7. There. Okay. The next one, if f and g are integrable on a and b, then the integral from a to b of f of x plus g of x equals the integral from a to b of f of x dx plus the integral from a to b of g of x dx. So we can just take the integral of each one of our functions separately and then add them together. Number 5, if k is a constant and f is integrable on a and b, then if we have a constant right here, that k is our constant, we can pull it out front, just like we can do with derivatives. So it would be k times the integral from a to b of f of x dx. This shouldn't have that 5 right there. Sorry. And then our very last one, if k is a constant. So I want to kind of draw a picture of this. Let's say k is right here, and we've got from a to b. Well, if I'm just taking the integral of k is just that's just a horizontal line, right? Because k is a number. It's like 2 or 7 or 15 or -4, but it's just a line. Well, the area under that curve is just a rectangle, right? What is the height of that rectangle? It is k. What is the width of the rectangle here? B minus a. So our area would be k times b minus a. not sure I put an example of this in there, but in case I didn't. So, like, if I had the integral from 1 to 4 of 5 dx, what would the area of that, what would the area under that curve there be? It would be 15, because I just have 5 times 4 minus 1, and that would give me 15. So from 1 to 4 is 3. You multiply it by the height of 5. So 15 for that. I might have put an example in there, but I think I might have forgot it. Okay. Questions? All right, let's look at what types of problems you'll see for this. One thing that you're going to see is that they might give you information about your interval. So they might tell you the integral from -2 to 8 of f of x dx is 10. From 3 to 8, it's -6. And from 0 to -2, it is -3. Okay? So let's start with number 1. The integral from -2 to 0. So if we look up here at the information they've given us, it's a lot like that third piece of information they gave us. The only difference is that the intervals are switched, right? Rather than going from 0 to -2, which, by the way, is a backwards interval, you're going from a higher number to a lower number, is -3. So the integral from -2 to 0 would just be +3. For number 2, we want to know what we would get from 0 to 3. Well, that's the part that's kind of missing here, right? We've got from -2 to 0, and we've got from 3 to 8, but we don't know what we have from 0 to 3. However, they did give us the entire length from -2 to 8. So we would know that the integral from -2 to 0 of f of x dx plus the integral from 0 to 3 of f of x dx plus the integral from 3 to 8 of f of x, right? And you wouldn't necessarily have to write this out. But we would know those three pieces together would equal the integral from -2 to 8 of f of x dx. Well, we have most of that information. We know the integral from -2 to 0 is 3. We do not know the integral from 0 to 3 of f of x dx. That is what we are trying to find. We know from 3 to 8 is -6. And we know from -2 to 8 is 10. So if we're trying to find this integral from 0 to 3 of f of x dx, we could just add the 6 over here and subtract that 3. And we would get here 13. So we get an answer of 13. The last one asked me for the integral from -2 to 3. Well, I just found 0 to 3. I also knew -2 to 0. So I could just take the integral from -2 to 0 of f of x dx. And I'm probably writing down things I usually wouldn't if I were not given notes. F of x dx. That should give us the integral from -2 to 3. So the integral from -2 to 0 was +3, and the integral from 0 to 3 was 13, and that gives us 16 as our answer there for number 3. Okay, questions? Let's try another one. we still have the integral from negative 5 to 1 of g of x equals 8. We've got the integral from 1 to 5 of g of x is negative 2. And then it asks us for several different things. So the first problem asks us for the integral from negative 5 to positive 5. So when we look at this one, Lily, what would we do to find the answer for this one? Good. Right. So this is negative 5 to 1. This is 1 to 5. If we put those two together, it's going to give us from negative 5 to positive 5. So we would just say 8 plus negative 2, and we will get 6 for our answer there. Okay. For number 5, I've got two things that are added together. I can take the integral of them separately, right? So I don't always write this. A lot of times I'm just doing this part right in my head. I'm taking the integral from 1 to 5 of g of x dx plus the integral from 1 to 5 of just 5 dx. Right? So, integral from 1 to 5 of g of x, I've got that. It's given to me up here. So this is just negative 2. Then I've got to take the integral from 1 to 5 of this constant, which is just 5. So here is where I use that rule for my constant. Destiny, what would I do for that one? Very good. 5 times 5 minus 1. There, because the length of that interval is from 1 to 5, that's 4. And we'd multiply it by the height, which is 5. So we'd get negative 2 plus, this is 5 times 4, which is 20. So we would get 18 for our answer. Now, 6 is a little bit different. We are not going to use that constant rule for 6 because this 3 right here is a coefficient. It's multiplied by g, so we're going to pull it out front. So we would have 3 times the integral from negative 5 to 5 of g of x dx. And this part, the integral from negative 5 to 5 of g of x dx, we found that over here on number 4. So we would just have 3 times 6 there, which would also give us 18. Okay. Questions? Okay. Let's look at the next part. Okay, so the graph of the function f on the interval from negative 4 to 4 consists of 3 line segments and 2 semicircles, as shown in the figure above that I put below. What is the value from of the integral from negative 4 to 7? Okay, so this is a problem that you probably might have known how to do even before I showed you these properties. Because what we were doing when we were finding area under the curve is we were just splitting this into sections that we could find the area of, and then we were adding them all together, right? So that's what you're going to do here. So, like the area of this is 2. And then you've got this semicircle, but it is on top of this rectangle, so I'm going to make this part right here is 4. And then I've got a circle with a radius of 2, so that would be pi times 2 squared, which would be 4 pi. But I've only got half of the circle, so I'd have to divide that by 2, so I'd get 2 pi. So this part right here would be 2 pi. And then this little tiny triangle right here, that's just 1/2. Then I also have these sections right here, but they are below the x-axis. So what do we know about sections that fall below the x-axis? They're negative. So this little half circle right here, it is pi times 1 squared, which would just be pi. but we've got to divide it by 2 because it's only half the circle. So this is pi over 2, and it is negative because it's below the x-axis. And over here, we would have 1/2 times 2 times 1, and we would just get 1. But it is also negative because it's below the x-axis. So if we take all of our little sections, we would have 2 plus 4 plus 2 pi plus 1/2 minus pi over 2 minus 1. So if we take all of our constants here, we've got to do 2 plus 4 plus 1/2 plus or minus 1. So that's going to be 6.5 minus 1, which is going to give us 5.5, but they don't like to leave it like that. So that is probably going to be 11 over 2. And then, we got 2 pi minus pi over 2. So we would have to get common denominators there. We would multiply by 2 on top and bottom here. So 4 pi over 2 minus pi over 2 would give us 3 pi over 2. So we would have 3 pi over 2 plus 11 over 2. And that is answer choice C. Okay, questions? Alright, we got just a couple more that we're going to do. For number 8, it tells us that the integral from -1 to 3 of 2g of x plus 4 is 22. It tells us the integral from 10 to -1 is 12. And then it tells us that we want to find the integral from 3 to 10. So, this one's going to have us going around the world a little bit. So, first of all, I really... this one's harder than I realized. Baby question. I should have. This one's kind of tough because if we think of this right here, if we think of breaking this down, we've got the integral from -1 to 3. It would be 2 times the integral from -1 to 3 of g of x plus the integral from -1 to 3 of 4. And we should have a dx with it. So should this. That would equal 22. So this part right here, this integral from -1 to 3 of 4, we can figure that out, right? Because that's just a constant. So, Hannah, what would we get whenever we do that? The integral from -1 to 3 of 4 dx. It's going to be 16. Because from -1 to 3, that's 4, right? And then the height would be 4. So we would get 16 for this. So I've got 2. So I've got 2 times the integral from -1 to 3 of g of x dx plus 16 equals 22. Well, what's nice about this is now I can just subtract that 16. So I've got 2 integral from -1 to 3 g of x dx is going to equal 6. What can I do now? I could divide off that 2. And so I'd have the integral from -1 to 3 of g of x. I don't know why it does that. Dx equals 3. This is helpful because I have the integral from 10 to negative 1. And I also want to find the integral from 3 to 10, right? Well, I will know that the integral from negative 1 to 3 of g of x plus the integral from 3 to 10 of g of x should equal the integral from negative 1 to 10 of g of x. And those all should have dx's beside them, but I'm being lazy. Okay, so I just found this is 3. Thank you, Harper. Get started on your homework right now if you want to go. Okay, go finish the rest of it, okay? Finish the rest of it. Because if you want to go with D, let's come. So the integral from negative 1 to 10, what is it going to equal? It's going to be negative 12. And why negative instead of positive? The interval is flipped there. So negative 1 to 10 is going to be the opposite of 12. So we get negative 12. So now if we just subtract the 3, our integral from 3 to 10 of g of x dx is going to equal negative 15. And that is D. Yes. Why? Okay. Yeah, you usually do get in trouble when you go to the grocery store. That's true. Alright, so this last one, I know it's teeny tiny, especially on your page. So I will label this for you. It says the figure above shows the graph of the continuous function f. The regions A, B, C, D, and E have areas of 2, 14, 10, 27, and 4 respectively from 11 to 7. G of x equals 8 plus the integral from negative 5 to x of f of t dt. So if we label these areas, A has an area of 2, B has an area of 14, C has an area of 10, D is 27, and E is 4. Okay, so they're just giving us those areas. Clearly we can't find them because we've got curves here. It also tells us that g of x, if you can't see it there, it tells us g of x equals 8 plus the integral from negative 5 to x of f of t dt. So, it wants to know, is there any value such that g of x equals 0? Well, I know if I went from negative 5 to negative 5, then g of x would equal 8, because this part right here would be 0, right? So, g of negative 5 would equal 8 plus the integral from negative 5 to negative 5 of f of t dt, which would give us just 8 plus 0, which is 8. Now, over here, this next easy spot where I could actually find the integral would be at negative 1, right? Because I would be kind of limited to only these points where I know the area. Right here, I cannot find the actual value for anything but these points right here I've marked in blue. So if I use the next one, g of negative 1, that would be 8 plus the integral. the integral from negative 5 to negative 1 f of t dt, which would be 8. And right here, it would be minus 10 because that area is below the curve, so it'd have to be a minus for that, which would give me negative 2. Now that does not equal 0, but would it have to equal 0 somewhere? Somewhere in between. So we would say, does anybody remember the theorem for that? There's the theorem. It is intermediate value theorem. Very good. And we would have to say, since g of x is continuous, and it would be continuous because f is continuous, so integrating f is still going to be continuous. Adding 8 does not change anything. It's still continuous. So since g of x is continuous by the intermediate value theorem, f or g of x equals 0 on the interval from negative 5 to negative 1 somewhere. Okay. Real quick on that last part, it asks for the absolute minimum. So absolute minimum would be the lowest possible point. Remember that if g of x is 8 plus the integral from negative 5 to x of f of t dt, if we take the derivative, the g prime of x, what is it going to be? What's the derivative of 8? 0. It's gone. What's the derivative of the integral of f of t dt? It's just f of x. So this is the derivative. The derivative is going to have minimums at any place where we go from negative to positive. So it could happen at negative 9. Also could happen at negative 1, which thankfully we already found, right? And that would be it, right? The endpoints are possibilities, but in this case, you decrease to get here, and then after this point you're increasing, so it wouldn't make sense to check the endpoints here. We already found g of 1. To find g of negative 9, we would do g of negative 9 equals 8 plus integral from negative 5 to negative 9 of f of t, that is going to be minus 14, because although it's a positive, you're going backwards on your integral. So you're going from negative 5 to 9. So you'd have to make it negative when you put it in there. And so you'll get negative 6, and that will be your absolute minimum value. Except for it does ask for maximum. You have to do sort of the same thing with that also. The assignment that I want you to do is on that last slide. There. Yes, thank you, Luna. Sorry, I ran out of time there. Yes. What? Good job. Excellent. See how easy it is if you write faster? They're what?